Hello everyone, we are from Crux Intelligence. In next 30 minutes, we will share how we leverage Apache Ignite along with Istio service mesh in our product Crux Intelligence. Brief introductions about me and my colleague who will be presenting this topic. My name is Suman Das. I am a principal software engineer at Crux Intelligence and my colleague Ankita Sawant who is a senior software engineer at Crux Intelligence. So, what is Crux Intelligence? Crux Intelligence is an AI-based analytics tool that helps you to answer pressing business questions anytime, anywhere. It's an enterprise level AI which helps you to diagnose, predict, and prescribe what will happen to your business. Using AI, it will provide you personalized insights. User can ask questions in a natural language and can get actionable insights within seconds with automated visualizations. It's the next phase of augmented BI. You can think of it like Google for your business or Siri for your business. Moving on, how we leverage Apache Ignite along with Istio Service Mesh, we would like to talk about two main components. First, how we leveraged Apache Ignite to enable Google search-like experience in our product. Second, how we deployed Apache Ignite in Kubernetes cluster along with Istio Service Mesh. Let's start. Let's take a step back to see how Crux architecture looked like before the introductions of Apache Ignite. In Crux, we are using microservice-based architecture which is deployed in Kubernetes. We are using Apache Geoid as a caching solution. In Crux, we always wanted to be cloud agnostic, so we don't use any technologies which is specific to any cloud provider. But with Apache Geoid, we are facing some challenges like reliability. For example, there were frequent data corruptions and data loss. The Apache Geoid community was not very active. Apache Geoid doesn't provide native Kubernetes support, and also the query languages used by Apache Geoid doesn't provide all the SQL querying capabilities like aggregations, and there are many more. So we started looking out for some alternatives. Why we chose Apache Ignite? As we have seen in our product, users can ask questions anytime, anywhere and can get answers, right? So we wanted to enable Google search like experience in our product where the questions can be completed even while the users are typing questions. So that's why we wanted to looking for some technologies which can help us with that. But at the same time, we don't want to use any technologies which is specific for this use case. We also looking for something which can help us with our caching problem that we are facing. So as we all know, Apache Ignite provides a scalable, reliable, and has native Kubernetes support, and also it has various querying capabilities along with the text search, which becomes a natural choice for us. How we use, let's now see how we used Ignite in our product. We created Ignite cluster in Kubernetes with native persistence enabled, and then we use Spring Boot thick client which are connected to this Ignite cluster for various querying purpose. We use various querying capabilities of Ignite to query the data which is stored in the cluster. We have also used key value pair search also. Let's now see how to enable various querying capabilities in Ignite cache. We just need to add these annotations to enable the SQL search on a field on the cache present in the cache. We can also have the options to enable the index on that field just by adding some parameters. Similarly, to enable the text query, we have separate annotations which is available. We can just add this annotations on top of any field which will provide you a simple text search facility on that field. Underlining, it will create a leucine index on that field, on the data which is stored in that field. Leucine index is the same index which is used by Elasticsearch as well as Apache Solr to perform the text search facility. Along with SQL query and text search, we have also used key value pair store. To use key value pair store in Apache Ignite, we have used the JCache. So Apache Ignite provides an implementation of JCache, which is JSR 107, to provide the cache search capabilities. Let's now see how we have deployed Apache Ignite in Kubernetes cluster along with Istio service mesh. For that, I would like to call my colleague Ankita Sawant.
Thank you, Suman. Hello, everyone. So now let's see how we have deployed this Ignite cluster into the Kubernetes cluster along with service Istio service mesh. So before that, I want to give you the brief introduction about the what is the service mesh. So here in this diagram, what you can see, there are different layers of the implementations along with the business value. So here in this case, developer has to focus on all these layers if you are not introducing any mesh level strategy. So but with the service mesh, what we can do is we can get rid of all these extra layers, that is the retries, timeouts, tracing and monitoring, authentication and authorization, and we can just developer can just focus on the core business value. So this is the main advantage of service mesh. It's like the dedicated infrastructure layer which can sit on your existing architecture, and it can handle the service to service communication. And with the help of this service mesh, you can achieve all these age out constraints like the authentication, authorization, tracing and monitoring with the help of service mesh without changing your code. So this is the main advantage of service mesh. That's why we have chosen the service mesh. Now there are different implementations available for the service mesh, like the Nginx Ingress is there, Istio is there, but Istio service mesh is the widely used in the industry. That's why we have chosen Istio service mesh for our production. So now let's see what is the Istio service mesh and what feature it provides. Next slide, please. Yeah. So Istio service mesh is also like the dedicated infrastructure layer that sits on your existing architecture, and it will give you the number of features. So these are the main three features that for that we have chosen the Istio service mesh. Main is the traffic control, observability, and the security. So the main feature of Istio is its role in the traffic control. We can control whatever the traffic which is coming inside the cluster and going outside the cluster, and the traffic going between the services. All this thing we can control using the Istio service mesh. We can define the different traffic rules which are applied at the Istio service mesh level, and using that traffic rules you can control the traffic. Now next feature is the observability. So Istio gives us the different feature using which you can monitor the traffic which is going inside your cluster, and whatever the traffic which is going outside your cluster. So Istio gives us feature to trace the traffic, log the traffic, and monitor the traffic. So there are number of dashboards which are available in the market which you can integrate with the Istio service mesh to monitor your cluster. So we have used the Grafana dashboards. Using that, we are monitoring the different traffic inside the cluster. We are monitoring the resource consumption of a pods. Everything that is required to monitor regarding that Kubernetes cluster. You can use this Grafana dashboards along with the Istio service mesh, and you can monitor your services using the Istio service mesh. And the third and most important feature of the Istio is the security. So yeah, here you don't have to write any code in your application to secure your application. So as Suman said, that we are using this is Ignite cluster for providing the Google search like feature in our application. So whenever it comes like the search engine, so the data comes there, and whenever there is a data, it has to be secure. Like, so that's why what we wanted is whatever the data which is residing in our system, that has to be secure, as well as the whatever data that is in transit, that has to be secure. So data in transit, that can be uh, ensured by using the Istio service mesh. So Istio service mesh provides us the different features like the peer authentication, authorization, authentications. So using that, you can encrypt the traffic between the different services, and you can decide what strategy, whether you want to encrypt all traffic or whether you want to allow plain text uh, as well as the encrypted traffic within your service mesh. All these things can be configured using the Istio service mesh. So these are the main features. That's why we have chosen the Istio service mesh for our implementation, because we wanted to make our implementation secure, reliable, and we want to monitor everything. That's why we have chosen the Istio service mesh. Now let's see what are the different components of Istio service mesh which we have used in this implementation. So first is the Istio Ingress Gateway. Whenever you want to expose your application outside the world, then you have to create the Istio Ingress Gateway. So consider it like the Nginx proxy, which you are using in normal implementation. So using the Nginx, you can expose your application to outside. So for same applies for the Istio. So you have to use the Istio Ingress gateway, which will allow you to expose your application to the outside world. Now, next is a virtual service. Virtual service is nothing but a set of traffic routing rules. Whenever your host is address, how you want to route your traffic, that you can decide using the virtual service. So if you are considering the Istio Ingress gateway as the Nginx, then consider the virtual service as the ingress rules which you define for the Nginx. And the next part is the service entry. So as I told you, the Istio is nothing but the service mesh where different services are exposed. Now, if you want to expose any service with the extra port to the service mesh, then you can create this service entry. It's like it will describe the properties of service. So what happens when you deploy the multi-node grid gain cluster, you want to ensure that the different nodes of the grid gain cluster should communicate with each other. For that, we have to create the service entry, and we have to expose the TCP service discovery, TCP communication, and JDBC ports to the service mesh so that it will allow the communication between the grid gain cluster nodes. So that's why we have created the service entry. And the next is the peer authentication. As I told you, the security is the main concern. So to allow to encrypt all the traffic between the services, we have to create this peer authentication. The peer authentication will secure the service to service communication. So Istio provides the different TLS mode using which you can decide how you want to encrypt the traffic between the services. So there are these modes, that is unset, disable, permissive, and strict. By default, when you deploy the Istio service mesh, it has the permissive mode. It means it will allow the encrypted traffic as well as the plain text traffic. But I would recommend that for the production environment, we should have the strict mode so that it will only allow the encrypted traffic. Now let's see how this architecture will look like. If we are going to use this components, then how the architecture will look like. So this is how the architecture is going to look like. So here we have the Kubernetes cluster, and in the Kubernetes cluster we have implemented the Istio service mesh. So here you can see the dotted line which is representing the Istio service mesh, and then there are different components of the Istio. So that comes with the Istio deployment, like the Istio ID is there, control plane, data plane is there, discovery configurations are there. Then there is a main component, that is the Ignite cluster, and then we have the Ignite client, which we are going to expose to the external world. And you can see the ingress and egress traffic, all the communication which is going inside the cluster, going outside the cluster, and everything is encrypted. That we have represented by the lock icon. And you can see the all the traffic is going via the proxy. So when you deploy the Istio service mesh in your Kubernetes cluster, all the routing or all the communications happens via the NY proxy. That's why you can see every communication is going via the Istio proxy. It is not going directly to pod. Now let's see how we have deployed this. So for the Istio deployment, what we are using is we have used the Helm chart, which is available into the Istio community. So in our production environment, what we are doing is we are deploying everything using the Helm chart as a package, and that's why we have chosen Istio deployment using the Helm chart. So with the help of this link, you will get the step-by-step guide how to deploy the Istio using the Helm chart. And then once the Istio is there, Istio deployment is done. Now you have to do the certain configurations for the Istio. So first configuration we want to make is we want to allow the authentication or the communication between the services as encrypted communication. So for that, you have to create this peer authentication YAML. So this is the format of this YAML, where we are specifying the MTLS mode as the strict mode, and we are applying this configuration at this mesh level. That's why we have added the metadata namespace as the Istio system, so that it can be applied at the mesh level. Now let's see how we have deployed the Istio gateway. So this is how you can create the Istio gateway. So here we have exposed this gateway at the AT port, but this is just the sample application which we are showing here. But for the production clusters, we have exposed this gateway at the 443 port, that is the HTTPS port. And I would recommend that you should also use the 443 port in your production environment. And apart from that, we have used the host as a star here because we want you to run we want you to able to run this sample code on your local machine. That's why we have chosen we have kept the host as a star. But whenever you are using this configuration in your production cluster, you should use the DNS name in for the host. And this Istio gateway is applied to the proxy, that is the Istio ingress gateway, which is chosen by the selector, that is a label Istio ingress gateway. Now next, let's see how we have deployed the GridGain cluster. So we are using the GridGain cluster community version. That's why the nomenclature is like the GridGain cluster. In the architecture diagram, you have seen that we have used the terminology that is the GridGain Ignite client, but Ignite client and Ignite cluster. But here we are using the terminology that is a GridGain cluster and GridGain client for the deployment. So as I told you that we are using the Helm chart for deploying any component into the Kubernetes cluster. But when we were trying the POC for the Apache Ignite, we haven't found any ready Helm chart for GridGain cluster deployment. So that's why we have created our own GridGain cluster Helm chart with the help of the GridGain operator deployment. So taking inspiration from that, we have created our own GridGain cluster Helm chart. So these are the different YAML files which this GridGain cluster Helm chart contains. So we have the node configurations. It's like the normal configurations which are recommended by the GridGain cluster, GridGain community. Then we have the Istio components, which destination rule service entry you want to add. As I told you that if you have the multi-node GridGain cluster, you have to add the service entry. That's why you are seeing this file here. Then number of config map, then service account stateful set, and the storage class files. So we have deployed this GridGain cluster as a stateful set because we wanted to persist the data. And for the persistent, we have created the storage class. And as Suman told you, this Crux application is the cloud agnostic application. So we have kept all the storage class parameters as per the cloud provider. So we have kept all that parameters into the values.yaml file so that we can externalize it and we can change it as per the cloud provider. And apart from that, we have used the service account and the cluster role. We have used the RBAC authentication of the Kubernetes cluster to restrict who can access the GridGain cluster. We don't want all the application or all the services which are running in our Kubernetes cluster to access the GridGain cluster. There are restrictions which service can access the GridGain cluster, and to achieve that, we have used this RBAC authorization concept of the Kubernetes. For that, we have created the service account, and the service microservice which is created using this service account will only have the access to the GridGain cluster. So this is how the GridGain cluster Helm chart will look like. Now let's see how you can deploy this. So these are the steps if you want to install the GridGain cluster. So as we are just following these steps which are recommended by the GridGain community. So first you have to create the namespace as a GridGain. Then if you want to enable the Istio injection, you have to label that namespace with the Istio injection enabled. So this is the second command. And the next is the Helm install command, using which you can install your GridGain cluster. Now about that Istio injection, so most of the people follow that you can enable the Istio injection at the mesh level. But here what we are doing is we have enabled the Istio injection at the namespace level. That's why you are seeing the second line, which using which we are enabling the Istio injection. Now let's see next slide, which will tell you how you can create the GridGain client deployment. So here we are presenting the sample Spring Boot GridGain client deployment, and for that we have created this Helm chart. And this Helm chart will vary depending upon your GridGain client technology and the requirements. So as we are using the Spring Boot sample client, that's why it will have the deployment role binding service account and the virtual service. So as I told you that we are using the RBAC authorization. For that, we have created the service account and the role binding. So we are ensuring that this GridGain client is getting created using this service account, which will have access to the GridGain cluster. And we want to expose this application to the outside world. That's why we have created the virtual service. Now let's see how you can deploy this GridGain client. Now we have chosen to deploy this gradient client into the default namespace, and default namespace is by default there in your Kubernetes cluster. You don't have to create that. So you just have to label that namespace for the Istio injection. You have to enable that Istio injection. So using this second line, that is the kubectl label ns, you can label the default namespace for the Istio injection. And using the Helm install command, you can install the gradient client using this Helm install command. Now let's see. So we have kept all these sample files into this GitHub repository. This is a open source repository. You can just have a look into it. And if you have any queries or if you have any doubts, you can write email us to us on that email ID. And so to summarize this everything. So what we have achieved is we have used the Apache Ignite to introduce the Google search like capability into our application. So we have seen that we have used this querying capability to achieve this functionality, and we have not seen any caching technology providing this kind of feature. So as far as we know, so this is the big achievement for us. And the second thing is we are using the Istio. We have ensured that our application is reliable, secure, and we can monitor everything without making any changes to our code. So these are the things which we have achieved using this implementation. And thank you so much for giving us this opportunity.
Ankita and Suman, thank you. Thank you for that. Welcome back to the stage. So we do actually have a couple of questions that have come through. What I'm going to do is I'm going to show them to you so that we can answer them together. So the first one is from Surinder Kumar, and you should be able to see it along the bottom of your screen. And the question is, how complex are your aggregate queries? Does it include joining multiple tables? And what's the query run times with respect to time and throughput?
Yeah, so for this, the one which we talked about, right, the Google search experience, in that search, we are not using any kind of aggregations or joins for the search purpose, because the moment we start using aggregations or joins, it will slow down. So that's not the currently what we have used for pure search purpose.
Okay. Great. So Surinder, I hope that answers your question. And then the next question is, how long are you holding searchable data in the Ignite cache? Is it going to be in the cache as long as your system's up and running, or are you pulling it into the cache on demand? If not pulled on demand, have you ever faced node crash, and how did you address it?
Yeah, so we are holding the data till the lifetime. So basically, we have a separate pipeline where when the new data comes in, and we ingest that into our cache. And even if when the data invalidates, like for the business scenario where we know that the data is this is no longer valid for the business, we remove it from the cache in the background. The way we make it resilient, like we are using a multi-node cluster, and we are using full replica mode. We are running the cluster in the full replica mode. So even if one of the nodes goes down, we have all the data available in the other nodes. So that's where we are maintaining the resiliency. And even if it crashes, we are not losing out in anything. And we have also native persistence enabled in our cluster.
Great. Okay. I'm going to go back and see if we've got some more questions for you. So here's one from Damon Feldman. Suman and Ankita, I think you said you found Ignite and GridGain because your cache was inadequate and you needed a better cache, but found text search also. Were you looking for text from the start? And will you use AI or other compute processing?
Yeah, so as I said, right, in my talk, there are two problems that we are facing. We already had one inbuilt caching solutions which were giving us some problems. So we wanted to replace that. On top of that, in our product, we wanted to enable this search capability because in Crux, it's all about you can ask. So we want to make that ask more user friendly. So that's why we wanted to enable this search experience. So we started off, so we are able to solve these two problems with the help of Apache Ignite. Now going back to AI and other compute processing, yeah, we will see as in the use case comes in our product, we will try to leverage those, because once we have that capability Ignite built in our whole product pipelines and tech stacks, and since it is a cloud agnostic, we'll try to see what all other features we can get it from there, and we can add value to our product.
Great. Okay. Damon, I hope that answers your question. I see there's another question from Stephen Darlington. Did using the Istio affect the performance of the Ignite cluster?
Yeah, Ankita, if you can take this one.
Yeah. Yes. If you are introducing the Istio, it will add the latency in your application. So that is there. But the Istio provides some kind of tuning using which you can get rid of that latency. So we have done that kind of performance tuning, and that's how we have tried to get rid of the latency, and we have achieved the performant output. I hope that answer your question, Stephen.